Hi, everyone. Today we're going to be talking about correlation and regression. And we're going to focus on fitting a line to data, using linear regression to make predictions, talk about residuals, correlation, and the issue of correlation versus causation. First, let me bring your attention to this information here, this graph of school performance with the percent of students in the schools that are on supported lunch. So on the y-axis here, we have school performance, and that is measured by the combined math, reading, and writing scores of the students. So in a way, it has to do with the grades of the students in the schools. Each dot is a school, and on the x-axis, we have percent of students on supported lunch. So it's a measure of how much of the students in the schools need financial assistance. In other words, it's a measure of also the income of students, because if they're on financial assistance, they usually have less income. So the higher the percent of students on supported lunch, the higher the number of students that have a low income. And here we actually have another dimension, this Bush-Brogan performance-based grade, and these are grade for the schools. There's a grade that it's a system of grading for the quality of the school. And it's just a third dimension. We have one dimension here on the y-axis, school performance, another dimension on the x-axis, and we have this third dimension, but we can actually ignore this here for now, and let's just focus on the school performance and percent of students on supported lunch. And each dot is a school. So, or each dot or each square or each triangle is a school. What do we see here? Well, clearly we see that the higher the percent of students on supported lunch, the lower the school performance, the lower the grades of the students in the schools. And if we were to draw a line to see the trend, we can see pretty clear that there's a very clear linear relationship here. In fact, quite few things in the world actually have such a strong linear relationship. So it says that this graph shows us that poverty is potentially a major impactor, or at least associated with school performance. And the idea here is that we can fit a line between these points to see the linear trend of the data. And this is a negative linear trend that we're observing here. The higher the percent of students on supported lunch, in other words, the higher the poverty of students, let's say, for lack of a better term, on the schools, the lower the performance. So what's happening here is that we can fit a line to the data to identify the linear trend of the relationship. Just as we did over here, we can do it in all kinds of data points. Now, in one of the examples of the textbook, we have a perfect linear relationship, because the linear relationship is itself determined by, it's predetermined artificially, essentially. So the idea here is that the number of target corporation stocks you purchase, the more stocks you purchase, the higher the total cost. Why is that? Well, because each stock costs $64.96 plus a base rate of 5. And then so every time, let's say you buy one stock, it's going to be $64.96 plus 5, and that is going to be $69.96. And what is happening here is that we're creating an equation of a line to identify the linear trend of the data. In this perfect linear relationship here, this is the equation. So as I did, for example, if you want to find out what is the cost of two, if we want to buy two stocks to purchase, we did a calculation for one. How did we do it? Well, just put 1 for the x. This is the x, and this is the y. So if we know the x is 1. 1 times 6496 is 6496 plus 5. equals 6496. So y equals 6996 when x equals 1. So do the calculation when x equals 2. What's the value of y? Pause the video and calculate that. So if we calculate the value here is y equals 5 plus 64.96 times 2 equals y equals 5 plus 129.92, and then y equals 134.92. So when we have this the equation for a line, we can identify the value of one variable based on the value of the other variable. And that's the main idea behind fitting a line to data, and also the main idea behind linear regression, which we'll continue on the next video.